That one moves up and down, or back and forth, all the way if there's space to move in. But that one can only go up. That tall one can go any way it wants.
And this one?
On the diagonals. One square diagonal plus one square straight.
Let's play a game. I play white.
Okay, let's play. Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this episode, we are building this fun chess game inspired from chess.com. Thank you to Expo for sponsoring this video. The team at Expo is also a fan of the Queen's Gambit series and they wanted to collaborate with me on this project. If you are a subscriber of the channel, you know that I've always been using Expo. With React Native, I saw an opportunity to use web development skills to build truly native apps. And in turn, in Expo, I saw an opportunity to bring web development like agility to my React Native projects. And now the team at Expo is building interesting things with Expo application services to deploy seamlessly any React Native projects, even if you're not using Expo. You can easily build, test, and deploy to the Google Play Store and the App Store your React Native projects. So I definitely recommend that you check them out. Link in the video description below. I am pretty excited about this example because, first of all, we've never tackled any games on Can It Be Done in React Native. And so new types of example, and yet we're going to use the same old recipes that we always use with Reanimated 2. So I am pretty excited that we get to apply these recipes into a fun little game. Very satisfying. Which begs the question, how would we do this in React Native? Well, we're going to build the board in a Flexbox, pretty straightforward, and we're going to use a game engine to give us the possible allowed positions. There are many that exist in JavaScript. I looked at two. One that I really liked is chess.js. That's the one we're going to be using. It's very good and it's very lightweight. In fact, so lightweight that we could potentially run it on the UI thread. So I'm really satisfied with this library. So each piece has a pan gesture handler wrapped into it. So we move it around, and when we release, we check, is the position valid or not? If it's not valid, we go back to the original position. If it's valid, like here, for instance, we animate to the correct position. And then we go back to the JavaScript thread to get the new state of the game. So you see now it's white to play, so I cannot move the black pieces. So on the pan gesture handler, we have enabled equals is player black or white. And so now black can play somehow. And here we have the underlay, the yellow underlay, which it's a fun animated style. You're gonna love it. And so we can play the game nicely. So just really a fun game to implement with Reanimated 2. Before we jump into it, if you're interested to learn the fundamentals of gestures and animations, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user experiences that will run at 60 FPS, even on low-end devices. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. We are into VS Code here, and the first thing we're going to build is the background with the squares. So it's going to be pretty easy using Flexbox. So I'm going to do a container of Flex1. And we need 8 rows. And then in each row, 8 squares. So I'm going to do an array of size 8, do a fill, and then we can map over it. Value, we don't care, we want the index. Oops. And so we can return a row component. So the key is the index, and we pass a row as property, the index. Let me do the row component. So I'm going to do row props. So we have the row. Row props, and we return again. We're going to use a container of flex1. Sorry, up, some syntax errors. Flex1 and flex direction row. So we want the squares to be aligned in a row. And again, we create an array of size 8. We fill it with some values and we map over it, and we get the index. And we return the square component. Now the square component, we pass row and the column. I just can call this one, call, pass the key, which is the column. Maybe I can do it here as well. Now let's create the square component. So we have interface square props extends row props, and it has call as a number. So we can do square we have row, column, square props, and we return a view. Let me just do return again a flex1, and so we can display as text row and column. Text from React Native. Now we need the background color. So you see already the labels. So background color, this should be fun. Let's do if column is so even. So modulo 2 equals 0. It's let's say white or black. Looking good. And now we need to offset by 1. So we have we do column plus offset, and so offset if row is even, so modulo 2 equals 0, it's 1, or we offset by 1 basically, or 0. And that looks good. And I know, so here I put random values. I didn't know if it's black or white, but I know that, so it's a lucky shot, but I know that here the board is correct because we have the white square at the bottom right. So this is good. And let's do the labels. So the row, it's not 0 to 7, but it's from the bottom 1 to 8. So I'm gonna do 8 minus row. So yeah, now it goes from 1 to 8. That's good. And now here it needs to go A, B, C, D. So we want to create the letter. We want the letter, so we do from car code of column, but we need to add. So if column is 0, we want A, so we need the car code of A, and the car code of A is 97, but we can even do it a bit more flexible by doing car code at A. So here it's clearer what the 97 value is. That looks good, but now let's add some styling. Let's do background color, no, padding. So add a bit of padding, small one, 4. And we want to do justify content, space between. Looking good. We want all of these to disappear. So here, if the background color is white, the color is going to be black, and vice versa. So we just invert. So here we have style, color. I want to make it a bit bold, so I'm going to do maybe 500. But more importantly, we want to add some opacity. But it disappeared. Is it because of the color? No. What's going on? So it's not font size, it's font weight. Okay. Looking good. And here I want to do, I want the A to be at the right bottom. So I'm going to do align self, flex end. But now let's do the important stuff, opacity. Here we want the opacity to be 1 only if row equals 7. Perfect. And same here if column equals 0. No, that's not it. We want the letters only if the row equals 7. Yes. And the column if column equals 0. All right, so that's a good looking board. Now let's add the pieces. And I think the first thing I'm going to do here is to instantiate the game engine. So we're going to use chess.js. So I'm going to do chess equals use const. So use const is a lazy ref hook. You can use ref. If you are confused by use const, new chess to instantiate the game engine. And so chess from chess.js. That's not, no. The wrong import. That's the one. And we can use it now to have the state of the game into a React Native state. And that's exactly what we're going to do. So const state, set state, use state. And the state, default state is, so I want player to be black or white. So here default is going to be white. And then I want the status of the board. And here there is a method called .board that gives us the current state of the game. Now, we can use it to display the pieces. So the board are also rows and columns. So I can do state.board and map over it, and that gives us the row. And I'm going to use the index. So here it's going to be, let's use I. And then I can map over the rows to get the pieces. So it can be square. And now the square can be a piece or null. Null if there is no pieces. So if it's null, so if square equals null, we return nothing. And if not, we return a piece. Now, if we go to the piece, let me import piece. Oops. If we go into the piece component, it's just an image which has an ID. And the ID is the first letter is the color of the piece, and then the type of piece. R is rook, P is pawn, N is knight. So it's all usually the first letter, but K is king. So we take the second one for knight, bishop, queen. So here we pass ID and we get from square. So it's a string concatenation. And the first one is the color, so square.color. And the second one is the type of piece, so square dot type. This one is typed as, so you see it displays nicely here. This one is typed as a string. To get it as a key of pieces, we can do const. And here it knows that colors are black or white. It knows all the types of pieces, so TypeScript knows that here the ID is correct. So it's kind of cool that we can use these string template literals in React Native, and there is a small hack if you want to enable this into Expo SDK version 40 is to use the latest Babel core and then use the local Expo CLI, because if you use the global one, it's not going to resolve against Babel core. So now we need to make the pieces in absolute positioning. It's just so fun. It's already like pretty fun. So let's put an absolute position up. So we know already it's going to be wrapped into a pan gesture handler. But the pan gesture handler takes an animated view as a child. So animated view, oops. And we can add some style. We know that we need some position absolute, and we have the width and the height, which is of size. And size is it's a square, so it's height. It's the width divided by 8. So now they're all overlaid on top of each other. So we can pass a default position, which is going to be a vector. Should I call it position? Okay, let's call it position. So it's just a x and y value, which we can infer. So let me save this one, which we can infer here. So position, x is I times size. So I is 0 to 7. And so we multiply by size, and same on the y-axis. G, I, G, J times size. And so let me import it. Let me close this one. Let me use it here. So we get position. So transform. Translate x is position.x. Translate y is position.y. Nope, that's not good. So that would be g times size. You see it's not correct, right? I guess I got it. Yeah, now that looks good. All the pieces are, the board is valid and the pieces are valid. This is great. So now let's add the pan gesture handler around it. So let's move this into an animated style first. So we're going to create translate x, translate y. So here we go through the same process we always go through. Translate x, translate y animation values. Pan gesture handler, we start the gesture, we keep the offset value. We move, the gesture is active, it's offset plus translation that we assign to translate x, translate y. We end the gesture, we snap somewhere. Here, the only difference is that the offset that we usually keep in the pan gesture handler context, so that keeps the context we use to keep a state across different states of the gesture. Here, we're going to use into an animation value the offset, because we're going to need it in some other places. That's the only difference. Actually, let me create also the offset values directly. So offset x, use shared value, offset y, and translate x, translate y. And here we use the default position, position x and position y. So now this one becomes an animated style. So we are preparing everything before adding the gesture. So this is use animated style. And here it becomes translate x.value, translate y.value. Okay, that looks good. Now we can add the pan gesture handler. Pan gesture handler. And so on gesture event. And so here we know the drill. Oops. Use animated gesture handler. On active, we store the offset value. On start, sorry. So offset x equals translate x dot value. Offset y equals translate y dot value. When the gesture is active, we get translation x, translation y. And we know that translate x equals translation x plus offset x dot value. And same for y, and here it's dot value. So perfect. Let me import, and here it would be dot value. So I can move the pieces. Perfect. Now, obviously, on end, we need something to happen. And so on end, we're going to call back to the JavaScript thread. So on end, so I'm going to create a function here called move piece. And we want to invoke it on end. And so you see here I have my little plugin that warns me, ESLint plugin that warns me that I should use run on JS, which I'm gonna do. And I'm gonna pass the position where we want to go. So what I have here in the notation file, so I have the size of the board, of the square, and then I have two translation and two position. So the game engine knows A1, A2, and so on. So these are like all the positions, but we only know about translations, right? We translate by 50 pixels and so on. So to communicate with the game engine, we need to be able to go back and forth. So here, two translation from a point value, we get a position on the board. And here from a translation, no, it's the other way around. From a position, we get a translation. And here from a translation, we get a position. So here we have the translation. We want the position. So to position, x is translate x dot value, y is translate y dot value. And so we have the argument here, which is a position. We want also, so this is where we want to go. Offset x, offset y contains where we were. So actually I could also do here. So from offset x. So here we can do from 2. And so we have these two positions and we call back to the JavaScript thread to ask the game engine if these positions are valid. So position. Oops. So we actually need to use the game engine. So I need to pass it here as a prop. So I'm going to do chess. Add it as a type here. Okay. And so now we can ask him if the to position is valid. So we get all possible moves. So we do chess. So I get it here. So I think it's called moves, and I need to do verbose equals true. And we want, of all possible moves, we want the one where the from equals to from and to equals to 2. So if the move doesn't exist, it's undefined, so we snap back. So here we want x, y translation, which are the translation to which we snap, which we get, so we go from here positions back to translation, so to translation. And if the move exists, we go to to, if not, we go to from, if the move is valid or not. Now let's animate. So we do translate x dot value equals with timing to x, and same for y. So let's have a look. Something is not working. Translate. Okay, offset. You might have caught this one. So here it's offset y. Okay. So let's have a look again. Now it looks nice. So here up, or it goes back. This one is not valid. This one should be. So now we need to actually play the move if it's valid. So if move chess move, and should I just pass? So let's see if now black can play. Yes. So you see now, and so for instance, if I do this, so it's white has to play. So many things we need to do here. Let's start with disabling the gesture. So here we can still move black even if it's not black to play, and also implement the capture of the pieces. So when we play the move, we're going to call back to the board component. So we're going to do on turn. Here it is. And so here we have on turn, use callback. And so here we're going to set the state with the new position of the board and the player. So we're going to do set state. Player is if state.player is white, it's becoming black. And board is the new board. And here we have the new state of the board. So that implements the piece capture. If the piece disappears from the board, it will disappear from the state here. Oops. Okay. And here we have enabled, and the piece is enabled if state.player equals square.color. Here it's confusing because it's a piece, not the square. And we have enabled is a boolean. And let me update here. And we can use it here. Enabled. So here I move white. So the white pieces cannot move anymore. Here I can move black, and I can implement the capture of the pieces. Isn't that cool? And one thing we need to do, you see, is that the piece needs to be always, the active piece needs to always be on top of all the other pieces, and we're going to implement the underlay squares. And in order to do that, we need to know if the gesture is active or not. So we're going to create is gesture active, default value is false. If we start the gesture, it's true. And on end, it's false. Yes. So here we can use it into the style. So Z index is the gesture active, 100 or 0. And here it's important that so Z index only works if all the child are siblings, all the components are sibling. And so it's also important that the underlay squares stay siblings. So here I'm going to use a fragment. So the hierarchy stays flat. And so we can implement. So first of all, here we can check. So let me play one piece here. We can check that the piece is always on top. And you see, actually, we can even do better. I don't know if you saw it was very fast, but actually when we release the gesture, it animates and goes under. So I'm going to move this one to the callback here. Up. Perfect. And let's implement. So we have 2 underlay squares to do. So animated view. And it's from and to. So let's do from first. It's an animated style, background color yellow with some opacity, something like this. And position absolute, size. And so here, actually, the piece, even if it's at rest, it's not going to be 0, it's going to be 10 because it needs to be above these squares. So I have a double import. And we need, of course, to add the translation. So you see the square here. And here I'm going to simply use offset. And we need to add some opacity if the gesture is active. So opacity is gesture active. True opacity is 1, if not 0. Something is off. Translate offset X. It's always, you see, because of this. But these things happen. Looks good. Like to play. And now let's do the 2 position. So we're going to copy this style. And up. And now this one, it's not offset X. It's the position. So let me... So here we're going to do something funky. So we need translation, translate X, translate Y, convert it into a position, so round it, and then go back to the translation. So I think I'm going to do something like pose, translation equals. So we go to position with translate X. So from translate X, translate Y, we want A1, A2, and so on, and then go back to a translation. I mean, let me just to show you what I'm doing here. Let me just use the translation directly. Up, translate. Translate Y. Okay. Translate, sorry, I'm getting up. Okay, so you see, now it moves like this. But if we go to position and then back to translation, it's gonna do what we want it to do. And so this one becomes tr.x, tr.y. Let's have a look. And so, no, translate Y. So here again, always the same mistake. So you see, now it works nicely. Isn't that cool? It gives me almost goosebumps because I've played so much on chess.com. So now black has to play. And we have the piece capture. So white, up. Guys, I hope you enjoyed this example. Thank you Expo for sponsoring this video. The team at Expo is working on really interesting things so we can build, test and deploy any React Native apps seamlessly. So I recommend that you check out Expo Application Services, link in the video description below. That was the first time we do a fun little game in React Native. Hopefully that's not gonna be the last time. So I am looking forward to talk to you soon, and until next time, happy hacking.